Alright, hello Year 9, it's Mr. Stevens here. What we're going to be going through here is some examples to help you with your revision worksheet. First one I have for you is just addition and subtraction of algebra by collecting like terms. So in this first example over here, 3x plus 2y plus 4x plus 7y, we have two pairs of like terms. That's the x's and y's. So we're going to have some term here for x and some term here for y. We have 3x and 4x, so all we have to do is add the coefficients of x. And again, we have 2 and 7y, so we just add the coefficients. And that's our answer. Things get a little bit more complicated in this second example because we actually have a minus 3xy plus 4x plus xy minus 6x. So again, we have two pairs of like terms. We have an xy term and we have an x term. We can deal with the xy terms fairly easily. We just add the coefficients, 3 and 1. But when it comes to the x term, we are adding the coefficients, but now we have 4 minus 6, which is minus 2. And that's our answer, 4xy minus 2x. And again, one last example. Again, two pairs of like terms, ab squared and ab. And remembering that here we have BA and AB, these are like terms with each other because the order of the B and the A doesn't matter. But we have minuses on both pairs of like terms here, so when we're adding all the coefficients of AB squared, we have 8 minus 5, which is 3. And then when we're adding the coefficients of our AB terms, we have minus 9 plus 3, which is minus 6. And that's the solution. Moving on to multiplying and dividing algebraic terms. Multiplication is a fairly simple process. What we're doing is here we have 6x times 5xy, so really what that means is just multiplying everything together. So it's easier to deal with the numbers first. 6 times 5 is 30. Then we have x times x, which is x squared, and then we just have a y left over in the end. So this is how we multiply algebraic terms. We write it all out, all the individual terms, and just multiply everything together. That's example A. And example B over here, dividing when we have algebraic terms. 12a squared b over 3ab. Again, it's a good idea to start with the numbers. 12 divided by 3. 3 goes into 12 4 times, and 3 goes into 3 1 time. Now, we have an a squared on top and an a on the bottom. That means we can cancel one of these a's on the top with the a on the bottom. Because remember, what a squared really is a times a. So we can cancel one of these a's with the a at the bottom. And we also have a b on the top that we can cancel with a b on the bottom. And the reason we can cancel an a and an a and a b and a b is because if we remember, anything divided by itself is just equal to 1. And that's the same when we have letters. So after we've done all this cancellation here, all we're left with is an a, so our answer is just 4a. Okay, adding and subtracting algebraic fractions. In this case, for the first example, because we have the same denominator of 5, we can simply do the addition from the top, and then this becomes the same as when we were collecting like terms in our first example. All we do is add the coefficients of x, which is 1x plus 2x is 3x. And then again over here in example 2, we have the same situation. We already have a common denominator of 3, so we can simply do the subtraction of the numerator. And again, it's the same process as collecting like terms. We have 7m minus 5m, so we take 5 away from 7, and we have 2m left. Now, in example 3 and 4, things get a little different because we have to change to a common denominator. In this case, we're going to choose common denominator of 20. Remember, the easiest way to find a common denominator if you don't know what it can be is to just times the two denominators together, and 4 times 5 equals 20. So we're going to choose that as our common denominator. Now, what we have to do to each of these fractions now is we have to do the same thing to the top that we've done to the bottom to keep the value of the fraction the same. So because we multiplied our 5 here by 4, we have to multiply our top by 4. So in this case, nothing happens to the a, we just multiply the coefficient of a by 4. So we end up with 12a. And then over here, we multiplied our 4 by 5 to get to 20. So we've got to multiply the top by 5. And again, nothing happens to the a, we just multiply the coefficient 2 by 5. And we get 10. So now we can continue with the exact same process as the first two examples. We can just do the addition at the top, which is the same as collecting like terms. We just add the coefficients of a. We end up with 22a. And we can actually simplify this fraction a little bit because 2 goes into the top 11 times and it goes into the bottom 10 times. And on our fourth example here, we could multiply our denominators together to find a common denominator, but we can actually take a shortcut here because 5 goes into 10 2 times. So we can actually just use 10 as our common denominator. And that means we don't have to change the second fraction at all. To change our 5 into 10, we multiply it by 2, so we have to multiply the top by 2. And again, nothing happens to the n, we just multiply the coefficient by 2, so we end up with 4n. And now we collect our like terms. 4n minus 1n is 3n over 10. And that's adding and subtracting of algebraic fractions. Now, multiplying algebraic fractions is a bit of a simpler scenario because all we do when we multiply algebraic fractions is we multiply the top by the top and we multiply the bottom by the bottom. So in this case, we just end up with AB over 6. And again over here, it doesn't matter if you have pronumerals on the top or the bottom. We just multiply top with top and bottom with bottom. So 2x times 6 is 12x. And 3 times 5x is 15x. Now we can actually simplify this fraction. X on the top and bottom will cancel. 3 goes into 12 4 times, and 3 goes into 15 5 times, sorry. So dividing algebraic fractions is similar. Excuse me. We leave our first fraction the way it is. We change our divide to a times, and then we flip the second fraction to what's called the reciprocal. The reciprocal of a fraction just means you flip it upside down. That's what we've done here. The reciprocal of x over 3 is 3 over x. And now we can do multiplication of the fraction the same way we did it before, top with top and bottom with bottom. 3x over 5x. And same thing over here. We leave the first fraction the way it is. We change the divide to a times, and we flip the second fraction over. And now we can times top with top and bottom with bottom. 2ab over 4b. And we can simplify this fraction by cancelling the b's. 2 goes into 2 once and into 4 twice, so we end up with a over 2. Technically, there's a 1 here in front of the a, but remember when there's a 1 in front of the number, we don't usually write it. Now, some examples of expanding brackets. Remember, when we're expanding brackets, we take what's in front of the brackets and we just multiply it in to both terms inside the brackets. So here we have 2 times x, 2 times minus 3 is minus 6, and we have this 3 just hanging out on the end here. So we simplify it, minus 3 plus 3 is minus 3. And that's our answer. On our second example down here, again, we multiply the 3 into the brackets and end up with 6 plus 3y. And we've got our plus 4y on the end to deal with. So now we just collect like terms with the y's, and we end up with 6 plus 7y. Now here we have a ladder out the front, but it doesn't change the process we follow. We multiply the 2a into the brackets, and we end up with 2a squared, 2a times a, and 2a times 5 is just 10a. Then we have a plus 3a here that was outside our brackets, so now we collect like terms again. 2a squared plus, add the coefficients of a, 10 plus 3 is 13. Now we have 2 sets of brackets here to expand, and we also have this negative to deal with on our second set of brackets. Let's deal with the first set of brackets first. A times a is a squared. A times 2b is 2ab. Now, when we're multiplying this 3 inside our brackets, the minus actually has to come with it. So minus 3 times 3a, we just multiply the coefficients. The a stays the same. 3 times 3 is 9. And then minus 3 times b is minus 3b. Now, we can't actually collect any like terms here because none of these 4 terms are like terms with each other. So that's actually our final answer to that question. This is the last type of question we're going to come across here. And this is the opposite process of expanding the brackets. So we have this term here, these 2 terms here, 2x plus 2. And what we need to do is we need to think of the highest common factor between these 2 terms. What's the biggest number that we can divide by 2x and by 2 and get a whole number? In this case, it's pretty easy to see that the highest common factor is 2. So what we do is we write 2 down outside our brackets, and now we divide 2x by 2, and we get x, and we divide 2 by 2, and we get 1. And the easy way to make sure that you've done factorization correctly is to now expand these brackets, times 2 by 2 and times 2 by 1, and you should get this expression up here. And we'll see that that's what we get. If we times 2 by 2, we get 2x, and if we times 2 by 1, we get 2. And that is what we started with, and that's what we want to see. So moving down here, we have 2 terms, 2a plus a. So the highest common factor here, the thing that we can divide both terms by and get a whole number answer, is actually a in this case. So a goes outside our brackets. We divide 2a by a, and we get 2. We divide a by a, and we get 1. We can check our answer if we like again by multiplying the a into the brackets. And we end up with a times 2 is 2a, and a times 1 is a. And we're happy because that's the expression that we started with. Moving over here now to number 3. The highest common factor here, we'll think about just the numbers first. What's the highest common factor between 4 and 8? And the highest common factor here is actually 4. We can divide 4 by 4, it's 1. We can divide 4 by 8, it's 2. So the highest common factor is going to have a 4 in it. But we also have a common letter on both sides. We have a b on both sides. So our highest common factor can actually include a b. Now 4b divided by 4b is just 1. And 4b divided by 8b squared, we can cancel one of the b's out. 4 goes into 8 twice and into 4 once, so we actually end up with 2b here. And again, if we expand the brackets to check our answer, 4b times 1 is 4b, 4b times 2b, 4 times 2 is 8, and b times b is b squared. And that's the term we started with, so we're happy with 12x squared y and 16xy squared. We're going to look for a highest common factor. We're going to start with the numbers, something that can divide by 12 and 16. Because they're even numbers, we can always start with 2. 2 will always be a common factor of two even numbers, but if we can think of any number that's bigger than 2 that also works, we're going to want to choose that. And so let's check 4. 4 divides into 12. 4 divides into 16. But can we go any higher than 4? 6 doesn't work. 6 can divide into 12, but it can't divide into 16. 8 doesn't work. It can divide into 16, but it doesn't divide into 12, so I think we're going to choose 4 for our number. And now we have an x on both sides, so we can have an x in our highest common factor, and we also have a y on both sides, so we can have a y in our highest common factor too. So now 4xy divided by 12x squared y, 12 divided by 4 is 3, x squared divided by x, we can cancel the squared, and y divided by y, it will just disappear, cancel out. Now 16 divided by 4 is 4, x divided by x cancels out, and y squared divided by y, we cancel the squared, and we end up with 3x plus 4y. And again, if we want to just make sure we've done it right, we'll expand our brackets. 4xy times 3x is 12x squared y, and 4xy times 4y is 16xy squared. That's what we started with. Right, guys, now you are going to go on and do a worksheet that's going to have you practicing these kinds of questions. The solutions to this worksheet I'll post up on iLearn at the end of the day if you want to check it out.